This is the second video of Unit 6.1, investigating scatterplots, and I have Desmos open. And so the first thing we want to do is we need to input the data. So when we input the data, you want to hit the plus sign in the top, in the corner where you would normally put your equations, and then choose the table icon. And now you want to input your data. So the X column will be age, so that's going to be 1, 2, 3, 4, 5, 6, 7, and 8. And then the Y column is going to be the height. So we've got 70 and 82 and 93 and 98 and 106 and 118 and 127 and 135. Now when I look at my graph, I can see that I can't actually see the points. So we have to manipulate the graph. So we've talked about this before, how to manipulate a graph. One finger will move things around. Two fingers not on the axes will make the graph smaller or larger. My x-axis is okay because it's showing 1 to 8. My y-axis, however, needs to be brought down. There they are right there. So I'm pinching on the y-axis. Okay, my two fingers are on the y-axis right now only. So I'm only changing the vertical scale. Okay, so there's the points right there. Now, what we want to do is a thing called linear regression. And I'm going to go back to Notability, and I'm going to call all of this is what we call linear regression. Linear regression. Regression is the process of finding an equation that fits the data, okay? And because I'm trying to find the equation of a straight line that fits the data, it's called linear regression. So it's the process of determining the equation of the line of best fit. Okay, this is a line, the one that we found earlier by hand, that's a line of good fit, but it is full of human error. I can only be so accurate on a graph. My pencil can only be so sharp. I'm eyeballing everything, so it's not perfection. Linear regression, where you're getting the actual line of best fit, that's done through a mathematical formula, which we're not going to learn, but the software knows the formula. So it can do it all on its own. All right, so we're in, so just to look through here, open Desmos, click on the plus sign above the area where you input equations and choose the table icon. Input the data into the table. That's where we are. All right, taking note of the labels on the columns of the table. So we have, actually, let me do, all right. So we have X1 at the top of the first column and Y1 at the top of the second column. So let me go back into the Notability here, or my document. Type in the following formula: Y1 tilde, that little symbol right there, equals mx1 plus b. So I'm going to type in exactly that. Y1, so with a 1, the tilde, you're going to have to go into, so you're going to have to click on the ABC in the bottom left-hand corner. The tilde is right here. Okay, there's the tilde right there. All right, and now we need to go back to the 1, 2, 3 screen. So y1 tilde equals, now I have to go back to ABC because I need an M. Oh, sorry, there's no equals, I'm sorry. Y1, now I lost the tilde. Let's try this again. Y1 tilde M, go back to 1, 2, 3, X1 plus, go back to ABC and pick B. And there's the line of best fit. Now, I can't draw on this and I can't bring your attention, but look in the box where, so above this one that I just highlighted, you see M equals 9.08333, and then B equals 62.75. Yours should be the same as mine. That is the M and the B, so that's the slope. So it's actually, so 9.08333 rounded is about 9.1, which is exactly what I got, isn't it? And then it's actually 62.75 is the starting value, or the y-intercept. So going back into my document, we got that y equals rounded 9.1x, which is different than what I got. I got 9.6. And then plus 62.75. That is the actual equation of the line of best fit. This is the line of good fit. It's not perfect. This is the line of best fit, is what Desmos get. How does it compare to the equation that you came up with? It has a lower slope but a higher y-intercept. All right, so that's how you do that. If you need to go through that again, rewind and go through it again, because I'm not going to do it again, you can take a look. All right, now making predictions. Use your line of best fit to estimate the following. So on the graph, how tall was Julie when she was 5 years old? If we're just using the line that I've drawn, at 5 years old, that's about right here. It's just above the actual number in the table, 106. It looks more like it's about 10, I'm going to say 108, according to my line of best fit. I'm going to do all the graph questions first. How tall will Julie be when she is 11 years old? Okay, well, when she's 11 years old, I'm going to have to extend my line of best fit, and I'm just going to make a bit of an extension here. And she's 11 years old along here. And it is going beyond my graph, but I think I can tell. This is 150, 160. I'm going to say she's going to be about 170 centimeters tall. How old was Julie at 100 centimeters tall? So at 100 centimeters tall, that's right here. Using the line of best fit. Again, I'm using the line. Don't cheat and say, oh, well, that's pretty close to right on that grid line. It's not on the grid line. She's a little older than 4, so I'm going to say 4.2 years old. And then how tall was Julie when she was born? Well, when she was born, that's when she was 0 years old. And according to this right now, it looks like about 61 centimeters. Then it says use your equation. So I don't know what your equation is, but my equation is y equals 9.6x plus 60.8. When she was 5, that would be y equals 9.6 times 5 plus 60.8. So 9.6 times 5 plus 60.8. That's 108.8 centimeters. How tall will she be when she's 11? I can be a little bit more accurate now because I have the equation and I can just substitute the number in. So 9.6 times 11 plus 60.8. It's actually 166.4 centimeters. I'm going to jump down to the last one. Y equals 9.6 times 0 plus 60.8 equals 60.8 centimeters. Now, how old was Julie at 100 centimeters? Well, the 100 centimeters is the y, so 100 equals 9.6x plus 60.8. So with equation solving techniques, I've got to bring the 60.8 over to the other side. I don't really have enough room here, so I'm going to take the 100 and subtract 60.8. That would equal 39.2, and then divide that by 9.6. And y equals about 4 point, sorry, not y, x. X would equal about 4.1 years old. Okay, so these are predictions according to my attempt, my human attempt of finding the equation of line of best fit, but technology gives us the actual line of best fit, and we can do all the same stuff. So now we want x equals 5. Let me take that x out of there and put a 5 in. So 9.1 times 5 plus 62.75. It's actually 108.25, which, you know what, they're all about the same. They're pretty close. Y equals 9.1 times 11 plus 62.75 times 11 plus 62.75 is 162.85. My prediction was a little bit high. My graph is a little bit high for that prediction. I'm going to jump down to the last one. Y equals 9.1 times 0 plus 62.75 equals 62.75. So she was actually a little bit taller, or we're guessing she was a little bit taller. According to the line of best fit, she's a little bit taller than what I predicted, not by much though. And then for the third one, 100 equals 9.1x. That should be a 1 plus 62.75. So 100 minus 62.75, and then divide that by 9.1, and I get 4.1. Okay, I'm going to stop this video and then continue on with the rest of the handout.